I'm going to discuss how to solve systems of linear equations by graphing. Okay? If you don't know what a system of linear equations is, I would invite you to watch my introductory video on systems of linear equations. Okay? So let me now continue. You may know that a pair of linear equations can have 0, 1, or an infinite number of solutions. It turns out that there is a geometrical reason why those are the only three possibilities. All right? Give me a minute to make three xy coordinate axes pairs, and then I will elaborate. Okay, so remember that a point is a solution to a system of linear equations if it satisfies all the linear equations in the system. Okay, so what that also means is that that point is located on all the lines that correspond to the linear equations of the linear system. Okay? So think about why two lines would not touch. Okay? That two lines that were in a plane. Can you see that the only way that two lines would not touch in a plane is if they were parallel? So those two blue lines don't touch, okay? And that pair of lines corresponds to a system of linear equations with no solutions. Okay? Now let's consider the case where a system of linear equations has one solution. When would two lines touch in only one point? Well, that would mean that they cross, right? So, for example, these two green lines cross, and there's one point that's on both lines where they intersect. Okay? So those two green lines correspond to a system of linear equations with one solution. Now, the last possibility is an infinite number of solutions. When would two lines touch in an infinite number of points? The only way that that could happen is if both lines are on top of each other. In other words, both lines correspond to the same line. Okay? So that purple line, okay, if you can imagine two lines on top of each other, you can't really see both lines because they're the same line. So that would correspond to a system of linear equations with an infinite number of solutions. Okay? You can use the geometrical properties of the lines that correspond to systems of linear equations to solve systems of linear equations. Just plot the lines and see where the lines intersect, if at all. All right, so let's do an example of that. So suppose we wanted to solve this system of linear equations. y equals x plus 3 and y equals minus x minus 3. So we can graph both lines and see where they intersect. So give me a minute to make a picture, and I will go ahead and graph those lines. Oh. All right, so y equals x plus 3, that corresponds to a line with a y-intercept of 3 and a slope of 1. So that is the blue line that I just drew. Y equals minus x minus 3, that corresponds to a line with a y-intercept of minus 3 and a slope of minus 1. So that corresponds to that blue line, and they intersect at the point denoted by that blue dot. So therefore the solution to this system of linear equations is the point minus 3 comma 0. All right? Let me do another example. Let's solve the following system of linear equations. X plus y equal to 1 and x plus y equal to 2. Once again, let me draw an xy coordinate plane. All right, now in order to help me graph the correct lines, I'm going to write each equation in slope-intercept form. So the first linear equation corresponds to a line with a y-intercept of 1 and a slope of 1. So that would be this line. And the second linear equation corresponds to a line with a y-intercept of 2 and a slope of minus 1. So that corresponds to that blue line. Notice that the lines are parallel. Therefore, this system of linear equations has no solutions. All right? Now, would you please do an example? All right, so pause the video and try to solve this system of linear equations by graphing. Okay? I'll go ahead and do it now as well. So for the first linear equation, I will rewrite it as y equals minus x plus 2. The second linear equation, I'll write it as y equals x. So the first linear equation has a y-intercept of minus 2, y-intercept of 2 and a minus negative slope. So that one looks something like that red line. The second linear equation corresponds to a line with a y-intercept of 0 and a slope of 1. So that looks something like that. The line does. So the solution corresponds to the point with denoted by that red dot, or 1, 1. How about this example? So y equal to 4 and y equal to x plus 1. So pause the video and work that one out now, please. Okay, so I'll do it as well. So let's see, give me a minute to make my drawing. So the first linear equation corresponds to a horizontal line with respect to y equal to 4. So I will draw that line through the correct point on the y-axis. And the second line corresponds, the second linear equation corresponds to a line with a y-intercept of 1 and a slope of 1. So that will look like this. Okay, so the solution corresponds to the point denoted by that red dot, or 3, 4. All right, so let's do one more example, one more exercise. Would you please solve the following system of linear equations? Y equals 2 minus x and 3x plus 3y equals 6. So pause the video and do that now, please. Okay, so I'll go ahead and work it out as well. Let me write the second linear equation in slope-intercept form. So I'll first divide through by 3, then I'll move the x to the other side. And you can immediately see that both linear equations correspond to the same linear equation in slope-intercept form. So that means that the graph that corresponds to this system is just going to be a single line. So it's going to have an infinite number of solutions. So I can show you what that line looks like. It's a line with a y-intercept of 2 and a slope of minus 1. So that's going to look something like this red line. All right, so the solution set, consisting of an infinite number of points, is the set of all points x, comma 2 minus x, right, where x x can be any real number. Can be any number. All right.